Okay, in this video, we are going to look at some of the questions from the EMSAT paper. Here, a rock is dropped from a certain height. That means you have got Vi is equal to 0, and it's allowed to hit the ground. The velocity of the rock is measured on impact with the ground, assuming there is no air resistance. For the velocity of the rock to be doubled before the impact, which of the following is required? So there were 4 options. So to decide the answer, first we will write Vf square equal Vi square plus 2as, the kinematic equation. Then we will write Vf square, Vi is 0, so we can write it as 0, plus 2ah, because we are talking about height. And acceleration due to gravity will be negative, but because we are interested only in the number, so we'll just keep everything as positive to get the relation between velocity and height. So Vf we can write as root of 2ah. I've taken square root on both the sides. Now it's saying that we need to make Vf double. So if we need to make Vf double, what should be done to the height? Obviously, there is a square root. That means the height should become 4 times, because you have a square root. So if I do square root of 4, I will get factor of 2 for Vf. That means Vf will be doubled. So when the height is made 4 times quadrupled, the final velocity will be doubled. Let's look at the next problem. Here we have got a portion of the circuit and the currents are given to us. Here we have to remember that current entering a junction should be equal to the current which is leaving the junction. So here this is 3 ampere and this wire is just bent. So the current should be same. Here also it should be 3 ampere. Then this 3 ampere and 2 ampere. You can see that 2 ampere is reaching and 3 ampere is leaving. That means this side we should have a current of 1 ampere, so that 1 and 2 can combine to give you 3 ampere. So this current here should be 1 ampere, so that we can get 1 plus 2. They both are reaching the junction. Junction means this point where the currents are meeting. They both are meeting this junction. So 1 plus 2 will give you 3 ampere. Okay. Now let's focus at this junction. Here you have 4 ampere reaching the junction, out of which 1 goes to the right. So 4 minus 1, 3 should go to the left. So we will draw that 3 ampere to the left. So the current reaching the junction is 4 ampere, 1 is going to the right and 3 should be going to the left. Now let's look at on this side. This is 5 ampere reaching the junction, out of which 2 ampere goes up. So 5 minus 2, what's left is 3. 3 ampere should be going to the right like this. So 5 amperes reaching the junction, 2 goes up, 3 goes like this to the right. And now we look at this junction. 3 ampere from the left, 3 ampere from the right, they should join and we should get a current of 6 ampere for I. So that's how the current should be, 6 ampere going